Good morning, ladies and gentlemen. My name is Zachary Smith. I'm joined here today with Christopher Logan, Nicholas DeLuca, and our consulting mechanical engineer, Gian Calisi. And we are Team Hasbro with Project Android. Android stands for Automatic End-Sided Dice Roll Identifier. Now, the most exciting part of playing any board game is rolling the dice. The die roll is left completely up to chance and determines whether you win or you lose. In saying this, a serious downside to playing any online virtual board game is the lack of incorporating this physical die roll. Players need to resort to using a virtual random number generator. Now, a random number generator can have an extremely simulated feel, and many players do not believe that this is true chance. So Hasbro's solution is to develop a prototype that allows a player to roll his or her own die from home, capture this value, and use in-game. Hasbro would be able to use this device as an add-on to their already existing board games. They will also be able to use the machine learning technology as a foundation for a variety of other uses regarding digitalizing physical inputs. Also, this product is completely unique to the toy and gaming industry, and as such, Hasbro will have an optimal market position to sell. This year, Team Hasbro was able to meet their best anticipated outcome by developing an advanced prototype that is portable, battery-operated, non-intrusive to gameplay, and has an aesthetic design. It is also able to identify both pips and digits and distinguish against false positives. You can see on the screen here a virtual 3D representation of our finalized project. This system diagram shows the scope of our project throughout the year. It was broken up into both hardware and software aspects. And to talk more on the hardware, I would like to invite up Mr. Christopher Logan.
Thank you, Zach. So we began the year off with nothing but just an idea. And this slide clearly shows that we have progressed greatly throughout the year. Now, from a hardware aspect, our prototype has three main goals. Goal number one is to detect a die roll. Goal number two is to capture an input for the software to process. And goal number three is to react to the die roll and clearly display a prediction to the user. Goal number one, detect a die roll. We detect a die roll using an accelerometer, which uses a shift in the Cartesian coordinate system. Then that is changed or converted into a digital signal, which is processed by the Raspberry Pi board through serial data transmission. Now, once we have detected a roll, we react to that roll using bright white LED lighting and non-reflective paint. This allows for a more clear picture so the camera can capture it. Now, the camera itself is housed within a removable tower insert. This is the correct height and angle so that the camera can get a clear, filtered image for the software to process. Once the software is done processing, we then clearly display our prototype's prediction using the LCD screen shown on the right. Now, Nick's going to come up and talk more about the software part of our project.
Thank you. So on the software side, we have one master script that was written in Python. This handles both the number and the pip classification. The scripts are split up into the pre-processing phases of both pip and number, and then the actual prediction phases. It was all integrated onto our Raspberry Pi board. Now here, we can see the pip detection. So it's a much more simplistic script that begins with detecting the blobs on the die after we take an image and then apply a binary mask to it. We use inertia and area parameters in order to filter out the die on the side. And once we have the top pips, we then eventually print those out to the screen. You may also notice that the processing for this is relatively quickly, as this demo is taken within real time. Now, the number script is the much more complex because this actually handles the machine learning portion. For the pre-processing, we begin by taking the image and then we filter out the contours. We have a grayscale and a binary mask that is applied in the bottom left, from which we extract the region of interest as taken in the photo on the top right. We extract the digits and then align them to the vertical axis. From there, we predict and then flip them over to see if they've been flipped upside down and predict again. We take the higher classification and then we eventually print it to the LCD screen. Now, the actual classifier was by far the most complex portion of this project. We had to implement a convolutional neural network, which is a computer algorithm which attempts to mimic the human brain in decision and process making. We fed it a data set which it identifies and learns from, and then eventually can pick apart patterns in order to properly classify upon a digit. Right here is our actual demo of the number identifier. Please note that we did speed up the processing time, because from start to finish, it takes around 25 to 30 seconds. This is, of course, an area of improvement. However, it went reasonably within our scope of the project. Now, in terms of the accuracy, the team is very happy with what we were able to achieve. You might notice in this next demo that it actually does have some faults, because it's extremely hard to configure the neural network to handle certain test cases, such as 0s and 8s, open to closed 4s, or even 6s, which in the very center has just enough space to look like a pip. So the team had to work around this. However, like I said, we're very happy with the accuracy we were able to handle. For any of those who would like to come by and actually test the demo out, we invite you to come and throw some dice. And with that, we would like to acknowledge and thank everyone who has been able to help us with this project. Thank you kindly.